Good afternoon, everyone. Thank you very much for joining us this afternoon. It's Joanne here from Rockflow Dynamics, and today I'm here with Elliot, who is going to present today's webinar. So today, Elliot's going to take you through an overview of the static modelling tools that we have available inside tNavigator. And those of you who might know, we have 4 releases per year, and it's been over 1 year since we did our last geology focused webinar. So we hope you'll be impressed with the significant developments and features that have been implemented since in the last few releases. And for those of you who have never seen the Geology Designer before, we hope to give you a thorough overview of our static modelling capabilities. So just to let you know that your microphone will be muted automatically, so if you do have any questions throughout the session, please just pop those into the panel on the screen and we will answer as many of those as we can at the end. And we'll also share the recording with everyone along with all of the questions and answers from the session as well. So I will hand you over to Elliot now. Thank you very much and enjoy.
Hello, good afternoon, ladies and gentlemen. My name is Elliot and I'm a geologist with Rockflow Dynamics. And this afternoon I'll be taking you through our tNavigator Geology Designer webinar. I must mention it's great to see so many names and sign-ups during today's webinar. I'll give you an overview of Geology Designer and an idea of our capabilities and functionalities within the software. So, when geologists build static models, you might think of four main reasons or 4 main purposes why we do this. So for visualization purposes, when we come into well planning, when we might be calculating our preliminary reserve estimates, and also for our front-end simulation. And today we'll focus on front-end simulation, and we believe this is where tNavigator can really come into its own. So we might compare different geological softwares and think about pitfalls or downsides to some of these. Is it unfit for simulation? Are the workflows heavily modulated? Can calculations sometimes be a bit laborious? And is cross-domain modeling seamless, or do we lose some geological accuracy? So let's first look at unfit for simulation. So the first thing is that we think about as a geologist, we think of our loss of heterogeneity and our upscaling of our model when we pass our static model into our reservoir engineers for them to carry out simulation. And when you get to that stage of handing your complete static model to the reservoir engineers, they begin to upscale the model. As I've mentioned, some of our geology is often altered and or lost. tNavigator combats this as our simulation engine was designed previously. We all know and love the simulation engine, meaning our more recent Geology Designer software was designed in a static modeling environment and it's aimed to feed into the simulation engine when we're happy with our static model. And by that, in layman's terms, I mean tNavigator geological models run more seamlessly through the simulation stage without a big loss of geological accuracy, where we have a middle ground where your static model doesn't necessarily need to be upscaled and you won't lose any of your geological data. And I'm just going to talk through this slide very briefly, speaking about kind of our modulated workflows, what we might be used to as a geologist, your initial data preparation, your image and your core interpretation, through to your data treatment, where you might modeling your petrophysical parameters, your structure and stratigraphic framework, your well correlation, initial facies interpretation, sometimes your variogram modeling when you want to look at your sills, your ranges, your nuggets, and you want to maybe create a variety of different variograms. Also your log conditioning and your cross plots, amongst other things. Moving into our seismic interpretation, our attributes. And if not your seismic interpretation attributes, then into your modeling methods, creation of your simple grids, your structural grids, your stair-step grids and your hybrids, and also into some of your input parameters where we can model things from our model original objects, such as our data, such as our faults, our horizons, our point sets, and we can start to clean up our horizons and our faults if we do so. Then we kind of move into our scaling up of our well logs, and we can use our averaging methods. We can start to QC our well sections, our statistics, using our histograms and other tools. And again, back into our data analysis, where we can start to create more variograms. We can start to look at our vertical proportion curves and also our correlation coefficient. And then moving more towards our facies and petrophysical modeling, We can start to look at trend maps, correlation coefficients, again intervariograms and our distributions of these. And then finally into our uncertainty, our static uncertainty, where we can start to run things, and also our volumetrics and uncertainties, we can start to calculate things like STOIIP, HPV, gross rock volume, amongst others. And then also, when we think of modulated workflows, you might think of the cost of these. These are often not integrated with one another. These are often separate packages. And if you want to go from your data treatment, your data preparation stage, through to your scaling of your well logs, and you have both of these packages, you might not, depending on the software you're using, have access to the structural framework package. That means spending more money, and this can be quite costly as a geologist working for an operator. Moving on, we might think of laborious calculations. We have to sit and wait around as geologists for calculations to run, whether that be property interpolation or creating hundreds of runs for our static uncertainty. This can take time, and time as geologists that we don't often have. tNavigator now has GPU fully implemented within Geology Designer as well as simulation. So this speeds up our process massively when we're carrying out workflows such as our static uncertainty and our property interpolation. So through using GPU, for example, this nice graphic we have to the right of the screen, just kind of reiterating and really emphasizing how quick GPU, or how much faster we can run things like property interpolation, for example, using GPU as opposed to CPU. You can see an hour and a half there to run a property interpolation as opposed to 6 hours and 40 minutes. Really speeding up by a factor of 4.4. Now this is a ballpark figure, and it will depend on what you're running, your type of property interpolation, the amount of properties you're modeling, and so on and so forth. But this really does emphasize and hit home how quick GPU can actually make your static uncertainty, your modeling process. And cross-domain integration is another issue that we often face as geologists when I want to build a static model that's fit for simulation. With our fully integrated package within tNavigator, this problem is somewhat lessened. Our user interface for tNavigator is the same for each of our modules, so tNavigator is a fully integrated platform where the geologist static model can be passed to the RE seamlessly, ready for dynamic properties to be added, model designer, or ready to be run through simulation stage. tNavigator really prides itself on being able to offer a fully integrated platform for all subsurface operations. And this is really a slide to just reiterate what we've just said, where we do have, our unfit for simulation, which prevents simulation. It can be quite laborious. We have our modulated workflows, often process driven. There's often a lot of licenses involved. This can take time as well to get access to. Time taken to run these applications, projects can often stall and crash. And when we're using, when we're thinking about cross-domain integration, we might think of importing and exporting from one project to another. Often this can be, data can be lost, it can take time to QC this, and often lost in translation. So moving on, how do we take these obstacles and challenges and turn them into solutions? Well, when we think about tNavigator, we think about scalability of your model, how we can pass this, seamlessly passed over at the geological detail without need for upscale when we go into simulation. We want our model calculations to be run quickly and effectively, so we can start to collate and analyze the results. And we also need to build our static model and apply it within each section of our integrated tNavigator software. And that's integration when I'm talking about geologists, geophysicists, working alongside reservoir engineers, working alongside production engineers. It's all fully integrated and able to work in tandem with one another, passing your model to and from each subsurface department. So from left to the right on the screen here, we have a breakdown of Geology Designer and what we see as our key workflows within Geology Designer. From your initial data handling stage all the way through to your volumetrics and uncertainty. Data handling covers the import of data, the transfer of data from other projects, transfer data to other projects. And again, I just really want to reiterate and hit home, this is our initial, so when you load into tNavigator itself. This is the initial screen that you see. So you have Geology Designer there on the top left, and you see all the other engines, other packages we have available within tNavigator also. And all you do is hover over Geology Designer, just that example of the mouse, click New, give your project a name, save it, and that pops your GUI or your geology user interface, as we would call it, and you're ready to start building your static model and importing your data. So back to our initial stage of Geology Designer. Now, like any project, we must handle and order our data sets. The data handling covers importing of data, the transfer of data from other projects, viewing the data as statistics, and QCing this data accordingly. So this slide really encompasses, this next slide, really encompasses our capabilities for analyzing and QCing. From our different calculation windows to our project exchange tools, where we can take data from another project or model and input it with our new model, our statistics tabs, where we can view particular numerical data, whether it be for a horizon, grid, log, or otherwise. Our message board, which is found below our GUI, which keeps track of our project, what you've loaded in data-wise. The message board can also be used to display errors that we might have, whether that be errors when loading in your data initially, maybe isn't in the correct format, or when using our calculation windows, if a calculation maybe doesn't provide the correct calculation you want to show, or there's an error that comes up, it will provide a message as to why this maybe hasn't worked the way you wanted it to. Within our wells table tab, we can QC our imported data, and the ellipsis tool that you can see highlighted there allows you to expand the table and look at your well data, whether it be well trajectories, well markers, logs, or otherwise. You can do things like take out any duplicates of data you might have, any errors that become quite obvious. You can take these out as part of your initial QC of your model before you start going to your initial model building. We can also use more visual QC methods like our histogram window, where we can view individual data sets of data, such as log responses. And in the settings tab found to the left of the window, you have parameters such as number of bins and steps shown, and showing data as value as percentages. So there's different ways that you can QC your data visually within the histogram window itself. You can also switch the histogram to cumulative or logarithmic, depending on what you want to show as well. So when we're happy with our initial data handling and our quality checking, we can then move on into our initial seismic interpretation. And I'm going to share with you the following demo. You will see some of our visualization windows and tools and how we build up our seismic interpretation over time, both in our 3D and our seismic windows, and our ability to generate 3D attributes to help us with this, to identify structures that we might not see in our normal seismic. I will now start with our first demo, run you through what we're doing and some of the other tools and functions we have available within tNavigator within our seismic interpretation window. I will also occasionally pause the demos just to further describe or explain some functions, whether it be further describing some of our calculations boxes, explaining the functions of some of the tools and numerous tool palettes, or pointing out where to click in some of the windows. So without further ado, let's begin our first demo. So what I will do is I'll pause the video here straight away just to give everyone an idea of our interface, or our GUI as I called it earlier, and what we have available visualization window-wise. So using the mouse here, I can show you our geometry objects down the side on the left-hand side. Over on the right here, we have our tool palette. This varies or changes depending on which window we're using to visualize our model. Along the top here, you have 2D, 3D cross sections, our wells table, a histogram, our seismic, and we can create as many of these for whichever window we're visualizing as possible. I will carry on the video now. So we're now initializing. We've loaded in our seismic. We have our inline and our cross line, and we can start to zoom in. For full use of the seismic interpretation window, we can start to see our faults, the horizons we want to pick. You can generate slices, as many as we need to for 3D volumes and 2D lines. And we can start to use some of our tools. So I will pause again here, just to highlight some of the tools we have available for well correlation. To give you an idea in well section view, so we have a tool palette on the right hand side where we have tools such as alignment tools. So here we're editing our horizon accordingly, using our 2D auto tracking. We start to making our interpretation within our seismic window. Start to correlate. Using a rubber tool, if we make a mistake, we can easily remove that, go back, carry on picking our horizon. We can zoom out, we can start to see our interpreted horizon taking place or taking shape. And we can start to also correlate across our interpretation. And then we can toggle on some faults for our initial fault interpretation. We can start to edit these, making sure that we're happy with it. We can move on to our seismic window. And what we here, we've generated a 3D attribute, and on this occasion we've used coherence. We have a number of 3D attributes we can use, and this just really helps us to see structure we may not be able to see if we didn't use some 3D attributes. So here we can enhance these structures, and we can start to pick our faults and interpret these further using our tools that we have available. We can just really start to see things, start to see faults that we maybe wouldn't necessarily see, or faults that we wouldn't necessarily see the full capacity of within our regular seismic window. And if we're happy enough with them, we can then come back into our 3D window. We can start to toggle on our faults. We can view these faults accordingly. We can start to toggle on some horizons. We can see the interaction between our faults and our horizons, which are ready to carry forward into modeling. We can toggle on our grid. We can show framework. We can change the transparency of this grid. We can toggle on and off our horizon depending on what we want to look at, what we want to model. This is the end of this demo. So when we've finished our seismic interpretation, what we'll do now is we'll move around and move into some well interpretation and correlation. So again, I'm going to show you a brief demo, and I'll highlight some of the key features and tools we have available. So what I'll do is I'll pause the demo briefly to start with and point out some of the key tools. So again, down the right-hand side here, if I use the mouse, you can see the tools available. So we have edit well selection, which is what we're using here. So here we have a horizon in 2D, and we can start to edit selectors and start to toggle on the wells we want to look at in our well section window. If I let this video run, we can start to connect these wells, the wells that we want to view in our well section window. And when we're happy with that, we can move on into our well section window, and we can start to look at our responses. And what I'll do again here, if I go back a tiny bit, is I just want to emphasize again what we see in our well section window. So we have our tool palette on the right-hand side. Then the left-hand side here, we have our logs and our log responses that we loaded in with our initial import data. We have our settings tab, and towards the bottom of the settings tab there, where my mouse is, you can see the toggled on log responses. We can drag these to separate tracks. We can show these as responses within one track if we want to look at, for example, porosity and permeability in the same track. And here what we have is our settings tab, where we can change our drawing style. So if you want to view that as color stick, for example, we can change it from broken line to color stick. And into our settings tab, we can start to fill these items accordingly, depending on what we want to look at, what log responses we want to look at. And you can see our color stick method. And then we can toggle on these markers. We can align our markers by horizon or by depth. Toggle on the markers we want to look at. And just to emphasize again, we have our full editing capabilities. And I will pause again briefly just to tell you what's going on. So this is our cross plot window. Here we have our V-shale data against our permeability data. And what we've done is we've applied a fascist template to our data to show our higher values here, which are our shale values, which we see in brown, and also our lower values for V-shale and perm, which we see for our sand and our silts. And this is done by wells. Just another data analysis tool that can be really used to effectively QC and understand your data, what you've initially imported in here. And we can also create a filter if we want to filter on, or we want to look at particular data set. We can apply a calculator statement to this to apply cutoffs if we want to look at particular. And then back into our 2D window, we can start to create some well attributes from our well correlation that we've done. We can go into our wells table, and we can start to view. So you can see our sand fractions that we've created for zones between the markers, and we can view this within our wells table, and we can start to QC this data accordingly. We can start to generate these maps from our well attributes, which we then can carry forward through into our geological modeling and geological interpretation. And we can add contour lines to make our map more interactive, and then we can put it on our wells in our 2D window. And we can start to play around with our interactive palette and change this accordingly. And then again, using our well selector tool, our brush tool from the right-hand side from the tool palette, we can start to correlate these, fully interactive, digitized maps. So our next step after well interpretation and correlation is to move on into our geological modeling section, where we can start to build, clean up, and QC our geological model. So again, as I just said, we can clean up these, we can look at our faults, we can quality check this, and we can look at our horizons, and we can make edits accordingly using a full list again in a tool palette on the right-hand side of our editing tools that we have available. We go in, and I'm just going to pause it very briefly just to show you what we see in our 3D window here. Again, we have our tool palette down the right-hand side, where we have tools available to edit horizons accordingly, and down the left-hand side in our geometry objects, we can toggle on what we want to view, our particular horizons, our particular faults that we want to maybe edit and exclusively show the interaction between these faults and these horizons. And in our settings tab, where we can show these faults, we can show the fault frame, change the fault color if we deem necessary, and we can change left lines, right lines, we can change the color, we can show different functionalities within the settings window. So we have our horizon toggled on here, and what we can do, we can use a split screen tool to have a fully interactive, easy working environment, and we can start to make use of our editing tools down the side. So here we're using our contour lens configuration, and we can start to edit these contour lines accordingly. If we notice any glaring errors in our contours, anything that we need to change for a particular horizon, we can start to edit these accordingly to make fast, easy surface and contour edits. And we can use our pool horizon tool to then smooth any peaks that we might have for our individual horizons. And some geologists, I really like this tool here, some geologists like to take our horizons and convert these into point sets. It just allows you to maybe work more closely with your data and really pinpoint the interaction between our faults and horizons. So here we've converted to point set. and then go back into our point sets. What we can also do here, if I pause this really quickly, is just show our distance between our faults. So we can alter this if we want to increase or decrease the distance between the faults, just to really start to interpret the interactiveness between our faults and our horizons. And we can use this distance from faults just to clean up our model so far. And we can do this for every horizon, and then we can apply this, run the workflow. We can then toggle off these faults, and we can really start to see the interaction between our major and minor faults and our horizons. So we also have full editing capabilities for our fault framework, where we can go into our faults, we can edit faults and our fault lines accordingly. We can pull these down if we see any glaring errors. Up and down, really interactive to use, really intuitive. We can just initialize that fault framework, and then when we're happy with that, we can toggle on all our faults. We can go back into our create grid by horizon of faults. I just want to show you here just a table at the top and a table below to show our horizon data and our fault data and how we can QC this. And we can also change things like the counts and steps, the horizon type, our fault lines, and the number of zones. So zones will be created between each horizon that you have toggled on. And then you can auto detect as well, like polygon boundary or otherwise. So we can alter these counts and steps, these horizon types accordingly. We can toggle on and off certain faults. And we're back into our skeletal grid that we've created. And we can create zonal properties just to start to show this grid, to show the interaction between faults and our horizons. And we can create user cuts to show different layers and different zones. And we can also then create cross sections to help QC us. We can take it into cross-section window. We can start to effectively view these horizons for our effective grid QC. And we can toggle on different zones that we want to look at. And again, going into our split screen mode, we can then view 3D and cross-section together. And back into our fault lines, and we can start to do some manual editing for fault lines. So again, the window we have open here just shows we edited our faults previously, and now we're editing our fault lines, so we can use the pull up horizon tool again, pull these horizons up to the fault so that we are happy with our geological model so far. We can start to really make effective changes, pull these horizons up grid by grid. So that was just a brief overview of some of the functionality we have in the geological modeling side of things. When we move on to geological modeling, we move now into our reservoir modeling section. So again, from our import of data, the transferring from project to project, our statistics tool we have available, and then how we can QC this. So again, we have our skeletal model here. We've changed the transparency and opacity so we can start to upscale these logs. We can start to visualize these within our 3D window. We can start to create our blocked wells. For this, we're using our fascies template, or our fascies template as our source log. We have different averaging types available, and we can treat the log as points. On this occasion, and again, we can alter the transparency just so we can see these. And then back into our effective QC analysis, we can QC this data within our histogram window, where we can view our fascies against our upscaled logs, just to see the difference. A fully interactive display, so we can analyze this and QC this in split screen. Our well section, we have our histogram window open, and we have our 3D window open all at once. And we can go to our fascies modeling. Again, going back into our creating grid by horizons and our faults. Full fascies modeling and petrophysical modeling capabilities. The space type, your objective functions, whether you want to include or exclude these fascies. And then we also have our variograms, which you can make for as many properties as we want to for geologists, for our model. And we can use these interactive variogram maps for all directions. We can change things like the range for vertical horizontal, and we can also change the sill and nugget effect accordingly. This is for our fascies too. So we have fascies or blocked wells for fascies, V-shale, net growth, and porosity. These are vertical proportion curves. We can view our different fascies, our sand, our sill, and our shale, and alter the distance between. And back into our fascies modeling, we can apply these variogram and these data parameters within our calculations window. We can apply these accordingly and then apply. We can start to build back into our 2D window. We can start to build our fascies model, which will assist us with our interpolation. We have property interpolation window here, where we can model by zone. We can condition for discrete properties. So over here, we're looking at our blocked well log for our porosity, and our variogram type is exponential. But like I said, we can model per zone and condition for any discrete property. So you can see the different properties within our models here within three separate 3D windows. And then using a cross-section tool, we can start to QC against our 3D window. We can start to QC the properties that we've applied to our model. And again, using a histogram window, we can QC this effectively using our data analysis tools that we have available. So we're happy with the reservoir modeling. We've done some property interpolation. We can then move into our volumetrics and uncertainty stage, where we can create our contact. We can start to model our volumetrics and model our uncertainties, our static uncertainties for our model. And we can also keep an eye on our workflow. So another short demo here. So we've toggled on our model in our 3D view. And we're now creating a contact, our contact input, creating contact by horizon. Horizon or Z value, we have the option, and we can change our Z value accordingly. Then we can apply this contact. Our contact then appears in our 3D window against our model. And we can start to go into our volumetric properties and calculate our volumetric properties, whether it be for general, for saturations, oil and gas. So our source data that we're inputting here. And our output data, we have our oil and gas zones, our oil zones, and our gas zones. And again, the same, we can model things like GRV, NV, which will all help us to again calculate our STOIC. We can display these volumetric properties. We can display each of these individually on our contact within our 3D window. And we can create a table from our property. So we can tabulate our data. And we can see all our output volumetric results there highlighted in the table above. And again, one of my favorite tools, we can go into our workflows tool. So down the side, we have all our input, all our auxiliary calculations, all our structural modeling, property modeling stages. In the middle there, we have our workflows. You can create as many workflows as you deem necessary for each individual part of building up your geological model. And then on the right here, we have our inputs, the initial data that you've inputted when you've carried out this particular workflow. So these are all green, which means they're good. There's no errors involved. And if we click on each individual one, as I've stated there, we can start to see the input parameters we originally applied to our model. We can test these, they're all green, all good. And save the project, give it a name. And then we can start to move into our static uncertainty. So we can start to run all these tests, all these runs, hundreds and hundreds of them. They'll all be calculated for us. We get our table showing our results. We can also do these cross plots, histograms, analysis. We can order these accordingly. Looking at field HCPV here, we highlighted. We can go into our histogram table and then view this using our data analysis tools again. We can see the weighting of them. And we can visualize all our results from our simulation. Our P90, our P50, and our P10 there. And our quantiles. We can see our pessimistic, our optimistic, and our average figures. for our STOA. You can visualize all these results and QC these accordingly. So moving on, that's our demos. That's our demos finished. What I really want to emphasize and drum home to all our listeners right now is that tNavigator is it's a fully integrated asset modeling workflow. We have integrated solution, a single executable, fully parallel reservoir to surface modeling. So I've shown you some static modeling here. We have our fluid modeling, our dynamic simulation, our well and VFP modeling, surface network modeling, all the way through to our economics modeling. And this is all within one user interface. This is all within one package. Everything works seamlessly, so it allows our reservoir engineers and our geologists and geophysicists to work together to create a model from start to finish. And just a thanks for listening, and now I'll take some of your questions and hopefully provide you with some detailed answers. I hope you enjoyed the webinar. And I'll answer some questions now. Thank you very much.
Thank you very much, Elliot, for the presentation. Let's see if we have any questions. Any questions? Okay, here's one here, Elliot. If I have an already built model in another software, like Trell, how do I continue to model build inside tNavigator? Do I have to build a fully complete model or go straight into the simulator, or can I pre-build the model?
So we have to have our model fully built to go straight into the simulator. But from our static modeling point of view, we build our model accordingly. We can also take in from other software a rescue file. So that's our 3D grids, all our import data, all our well data. We can take this rescue file from another software into tNav and then start to model appropriately and accordingly. And we also have a new plugin available for Geology Designer, where you can take your model or certain model parameters and some of your model data from other softwares from Petrel rather into tNavigator. And what we can do is take our data such as our well data and some of our modeling parameters into tNav and start to build up a model within tNav. So it's very seamless, very easy to use. Next question.
Okay, next question. Is FASHES/object modeling available?
Yes, FASHES and object modeling is available. We have different algorithms available to do this. We have kriging, SGS, MPS. We're also looking to further in the line include SFS, TGS, talks on object modeling, and MPS is also in our further development program.
Okay, next question. On the cross plots, are only 2 variables allowed? i.e., can you exploit PHIE vs perm and then color by tops zones VSH? Sorry for my reading.
The quick answer is yes, we can, definitely, 100%.
Okay, let's see if we've got any more. What capabilities exist for detrending, declusterizing, and support normalization in the pre-model data analysis?
We can get back to you. There's documentation available. I can get that to you. I can email that to you as soon as we're finished today.
Okay, let's see if we've got any more questions. We've got time for a couple more. Can I rebuild or take back any of my realization from the uncertainty back into the Geology Designer for visualization, editing example P90, P10 model?
Yes, we can pick any of our models, so P90, P10, P50. We can also pick P25, for example, P1, and we can update these parameters accordingly and apply and run our workflow. So yes, we can go back into it and we can change our P90, P10, P50 accordingly if we deem it necessary. Yes.
Okay, cool. One person's just asked, can we share the presentation? The answer is yes, of course. We'll share the full recording of the webinar, and then we can share the slide deck too, certainly. Let's just see if we've got any more. Can you build simple box models in tNav?
Yes, of course.
Cool. Okay, will we do one more question? What is the next step for Geology Designer? What are we expecting to see going forward?
So in future releases, so we obviously have our 4 releases a year, 0.1, 0.2, 0.3, 0.4, and what we endeavour to do is to include as many requests from clients as possible. So we are in constant contact, each office with Moscow, with our development team, just to push and implement as many new functionalities, new ideas that clients have as possible, and try and make these available and be implemented in software within Geology Designer as soon as possible. Yes.
Okay, cool. I think we've got a few more questions, but I think we'll finish it there for today. What we'll do is, if anyone asks a question that we didn't answer, we'll get those answered and we'll send out everything along with the recording of the webinar. And of course, if you do have any further follow-up questions, just get in touch with us and we'll be happy to provide more information. So thank you very much everyone for listening, and we hope to see you next time.